Greetings, travelers. Do you have any X11 amp breakout boards from Parallel Miner? Are they faulty, intermittent, dead? Well, I do. I purchased quite a few of these, and I've had quite a few failures as well. I have a friend that did that same thing, and he had a bunch fail in the same manner. I looked it up on the internet, and it seems to suggest this is a trend. I contacted Parallel Miner. They have a 30-day warranty, which in my experience is code for no warranty at all, and it turns out that's effectively true. They didn't want to do anything about it. They didn't care if it was in warranty or not. They told me I must be running it too hard. I need to shut my rig down to let it cool. That's why the breakout board wasn't turning on. Obviously, silly me. Even though I'm running these 60 amp power supplies at 40 amps in a cool environment with direct airflow, clearly it's my fault for not letting the breakout board cool, right? Okay, well, I'll show you how to bypass this faulty internal turn-on circuit and just have the power supply always on. It's pretty simple to do. What you do is, you see these legs here? I marked the important ones, this first one and the seventh one. Those you need to jumper with a piece of wire, resistor, low impedance, whatever. Just jumper those pieces. And you see 4 and 5 in that I marked with a different stripe. Those need to be connected with approximately a 22K resistor. You can do a little more, a little less, but this is the proper method that these power supplies see when they're in a server. This tells it it's inserted. This tells it, hey, I want you to turn on now. You could technically do this by just jumpering this wire to the 4th, but it takes about a ½ a watt more, so personally I would avoid it. It's dissipating that ½ a watt inside the power supply. Probably not ideal, but it does work with most power supplies. This method should work with all of them. So you look at the parts required. I just have regular axial lead resistors here, 22K, and I'm using a 3.3K as a jumper. It's just kind of easier for me. So you look here, it shows this thing has voltage present, and we're reading 244 volts. I'm going to turn it on. It does not. Classic. I'll unplug it. We don't want too many surprises while we're switching this thing up to the proper modification with permanently on mode. How I like to do this is tin the leads that are pertinent. Makes it easier to just stab the resistor right in. And then I grab the resistor that I prepared earlier. Keep the legs, smush it in. Oh boy, it's going downhill over here. Alright. That looks sufficient for the jumper. And you snip these leads, get them out of the way. Grab the other resistor and tin the other leads. These are number 4 and 5 from the left. Hippity boppity. Pop that in there like so. Smash a little solder on as well for good measure. Yeah, something like that. Wonderful. Okay, now you may want to put a blob of hot melt on there or something. You can see I staggered these so they won't smash into each other and short the leads out, but a little blob of some shmoo on there, not a terrible idea. And I'll plug this guy in, and it turns on. And it'll turn on no matter what. The button is now unresponsive. So this does kill the sequential mode where you could like daisy chain these guys. If your turn-on circuit is still intermittent, it may work, but I would just assume that that's going to be dead. Now, if you're wondering what breakout board you should buy for your HP common slot power supplies, these are the most common style that people call HP server power supplies. These deep in the mines breakout boards seem like the best play. I have no affiliation with this company, but this seems to be the best breakout board I've seen. One thing I like about them is they actually have 3 ounce on the copper layer. So the actual copper underneath here, the conductive bit that all the juice goes through, on this it's 3 ounce, which is kind of like the weight classification for PCBs. On most PCBs, it's 1 ounce. That's the standard copper weight, and 3 ounces is 3 times as thick. And you can actually see this green portion here. See the darker portion? Underneath there's a break in the copper. It separates. That's, of course, the design, but you can kind of see the step. Like, you could barely tell the shiny section. You can see the copper has thickness, but it's not that thick. Now, maybe difficult to tell, but you look at this one. You look at the edge of the PCB here. You can tell the copper is much thicker right there, the step here. So underneath here, the copper that actually conducts the power to all these pins, this is 3 times thicker than it is on most other breakout boards, which is totally unnecessary, because obviously these handle 1,000, 1,200 watts, but it does decrease the heating in here, and it'll improve the reliability, decrease the power loss in this breakout board, which is always a good thing. And they have a very simple turn-on circuit. It's just a switch, no resistors underneath here, no passive components even. It just jumpers these wires like I mentioned earlier. It's not the best turn-on circuit, but it is very reliable. And it does have a SATA input that'll turn this relay on, which will jumper those as well. So if you have a ATX power supply, you can plug the SATA into here, and then the ATX will trigger this guy, the server power supply, to turn on. So this is a pretty good option. I think this is probably one of the best. It's definitely the most bomber breakout board, but I don't see anyone that I'm super in love with. This one's good, definitely better than the Chinese ones, and better than the problematic electronic switches in most of these breakout boards. So for now, I think it's probably the best. Link in the video description.